Hello guys, in this video I'm going to be showing you how to make an OR logic gate using a transistor. So first what I'm going to do is I'm going to go ahead and get my transistor. I'm going to go ahead and put it onto the breadboard. I'm going to put both of them on the breadboard like so. I'm also going to go ahead and put my two 10,000 ohm resistors, and I'm going to start it from the base of the transistor and place it adjacent on the side of the breadboard. I'm going to do that for both in the circuit. Like so. Now that I have that, I'm going to go ahead and connect my soon-to-be LED onto the circuit, like that. And I'm going to go ahead and place my resistor, my 1000 ohm resistor, at the anode of the LED all the way to the negative side of the breadboard. I'm going to also do the same thing for this 330 ohm resistor. I'm going to go ahead and place that onto the cathode of the transistor, putting it onto the negative side. All right, so now we have all our resistors put on. Next, we have to put on the buttons. I'm going to go ahead and place the button right onto the here, onto this side of the breadboard. The button placement doesn't really matter. This on mine, I'm placing it over here, but you can go ahead and place it anywhere just as long as the wiring is correct. Otherwise, your whole entire circuit will not be operable. Next thing I'm going to do is I'm going to take my wire and I'm going to go ahead and put it onto the right side of the transistor. And then I'm going to plug that side onto the to the bottom part right here, actually. Bottom part right here, all the way onto the right side of this transistor, like so. I'm also going to go ahead and place these wires starting from the vertical side of this 1000 ohm resistor to the left side of the first button. And then I'm going to do the same thing for the other side, putting this 10,000 resistor, 1000 kilo ohm resistor right there to the first part right there. Okay. Next thing I'm going to do is I'm going to go ahead and place my jumper wire starting from the left side of the resistor all the way onto the positive side here, like so. And then what I'm going to do is I'm going to place my next wire. That will be this one. That is on the left side of this next transistor, all the way up right here, placing it like so. Next thing I'm going to do is place my next jumper wire that's onto the right side, like so. placing it onto the right side of the button, making sure that it's not on the A column, it's on the B column. And finally putting our last wire that goes just above the B column into the last column over here. Last column over here, like so. And then, of course, as we have our circuit completely done, we have to adjust these proper wires. I have this Arduino circuit board with the 9-volt battery with the little clip on there. I'm going to go ahead and plug that in. And then I'm going to put the wires on as accordingly. Positive with the 5 volts and the ground with the negative volt right here. And there we have it. We have our completed circuit with everything on here. So let me go ahead and explain what the OR logic gate is. Basically, what the OR logic gate is saying for every one input, there can always be a desired output, just as long as there is some sort of input in. In this case, the inputs are these two buttons right here. So if I were to go ahead and press this button right here, notice the LED would light up. If I go ahead and press this button right here, the LED also lights up right there, like that. So that would be an OR case where if I press this button, it'd still go on, or if I press this button right here, it would go on. Same thing if I were to click both, the LED would shine up bright. The reason why it's not shining as bright as the second option, like this, is because the current flow is being blocked by one of the transistors, to where instead of the bright light being at max, which is when both buttons are pushed, only when one is pushed, depending on the resistor that it's going through, the current on here would say if the light is shining brighter whenever the first button is pressed, the second button is pressed, or when both buttons are pressed. And again, following Kirchhoff's current law, it could determine which one. So how this whole entire circuit is being processed and how this whole entire circuit works. Basically, the 5 volt, which is from this red wire, goes from into the circuit. Essentially, in this type of OR circuit, it goes through one of the transistors. This transistor isn't blocking it, unlike the AND circuit is, where they're both connected in series. These are connected in parallel, which makes it to where if I click this button, the LED can still turn on. And if I press this one, the LED can also turn on. They're not both binded. There's not a constraint on here. The current still flows through it perfectly fine. But anyways, the current flows through this button. If I press it, it would start right here, bypasses this one because it goes to this transistor over here and makes its way all the way down here to the LED. So if I press it, the LED turns on. And same thing goes for this other button. If I go ahead and press it, the wiring goes through the 330 ohm resistor. It hits it, and the LED also turns on like that. The brightness, of course, differs because of the resistance from the resistors, but other than that, this is how the OR gate works, logic gate works. I hope you enjoyed this video. Hopefully it was very helpful. If you could go ahead and press that like button if you'd like to see more of this type of stuff. I'm also going to put a link into the bio for one of the content creators on YouTube that actually gave me inspiration for this whole entire circuit to begin with. That's it, you guys.